All right, good morning, everyone. Welcome to day 15 of the Rankin Technical College online AWD1100 C# programming class. All right, yesterday we went over and you did hands-on test number 2. Today we're going to continue on and we're going to go into chapters 6 and 7. I'm going to cover those for the next 2 days. I've decided a couple things. First, I've decided to make Friday a lab day for all students. And second, I pushed the due date for your homework for chapters 4 and 5 rather, from Friday at midnight to Sunday at midnight. So you've got a little more time to work on them. All right. Now I'm going to show you something, and please don't think you have to quick write it down because I'm going to email it to you. I promise today. A couple people had contacted me and said, man, you talked about having a tutor for this class. What's the status of that? This is the status. All right. There is going to be a tutor. His name is Jacob Weinrich. And that is his information. Again, I promise I will get you that information. I will email that today to you. All right. Evan literally just sent me this. It sounds like he's available Mondays, Tuesdays, and Thursdays, right when the class ends from noon to 4, and other times, but then you have to email him, if you're working or whatever, to request another time. All right. But again, I promise I will send this to you today. All right. So again, today and tomorrow going over chapter 6. Friday will be a lab. We'll continue on with chapters 6 and 7 next week. All right. Your completed hands-on test, your C# hot number 2, was due yesterday by midnight. All right. I haven't looked at any of them since you're going to have a lab day on Friday, and that's 2 days away. I plan on grading them then. All right. I will tell you that, just to bring this up to you really quickly, okay, I will be available Friday, of course, when you have your lab, except I got a call from my doctor, and nothing serious or anything, but he wants to see me on Friday. All right. And the reason I'm telling you that is the only time he could get me in was right after 11 o'clock in the morning. So I'm going to be leaving at about 10:45 so I can go to the doctor's office. And then when I'm done, I'll come back. So if you do have questions on anything, just email me and I'll answer them once I get back. I have no idea how long all of this is going to take. All right. So with that said, then let's go into the chapter. All right. So I'm going to start on chapter 6, and I believe I said this the other day, but I'll repeat myself to say that how to code and call methods, much of this information we've already gone over. Not all of it. All right. We haven't talked about optional arguments, named arguments, etc. We will talk about those in just a couple minutes. I'm not going to spend much time talking about tuples, T-U-P-L-E-S. All right. Tuples mean different things depending on how they're being used, but we'll talk about them a little bit. I'm not going to say to you, hey, don't ever use these, because if you want to use them, use them. That's not a problem. All right. I'm not going to talk about them much because to me, there are better ways of working with data rather than using tuples. I'm not trying to degrade them or anything else. If you read those 4 or 5 pages and you think these are cool, then by all means use them. All right. We'll also talk about events and delegates. Some of that we've gone over already. Finally, we'll look at another version of the future value app. I have not gone back and rewritten this one or anything, so I might just bring up the author's version. Not a real long chapter here, as you can see. It's about 30 pages. All right, so let's just continue on. So what is a method? All right. Actually, a method is basically what I've been calling, a lot of times at least, a function. All right. Is there a difference between a method and a function? Yes, technically. A method is what you use when you're working with object-oriented programming. A function is what you use when you're not working with object-oriented programming. However, C# is an object-oriented programming language. So, the words are basically used interchangeably. Now, imagine for a second that we were going to write some kind of a program. Okay, I don't care what it is, but we were going to write some kind of a program. And in that program, we were going to ask a user for approximately, 9 or 10 pieces of information. And what do I mean? Well, we were going to come in and ask the person to enter their first name, their last name. We don't care about middle names, but their address, their city, their state, their zip code, uh, let's say their email address, their cell phone number. All right, we'll leave it at that. What is that? About 8 pieces of information. If you were really writing your code in a modular type of way, if you were writing your code in a modular type of way, meaning that you're going to take all your tasks and break each task down into its own function or method, you'd have 8 of these. You would have one method to read in the first name, one method to read in the last name, etc. All right. Now, is that how most people do it? No. But it depends on the severity of what you're working on. What I'm going to show you today, if we have time, otherwise tomorrow, are going to be several iterations I wrote of a very simple calculator program. And I know we've done the calculator program already. All right. But I want to show you that there are different ways of writing this, but they'll all basically give you the same type of result. So why am I even bringing this up? Well, as your programs do get more complex, typically what's going to happen is you will be breaking your program up into more and more methods. You do that for a few different reasons. One reason is if you're going to break it up into enough different units or pieces or methods or whatever, if it's going to be a very complex application, you might have a whole team of people working on it. And then each person could work on their own piece, so to speak. All right. Another one is if you have problems with something. Now imagine that I did do this. So let's say that I did make 8 different routines. All right. And now for some reason, I'm having a problem with the zip code. And I don't know why, but I am. I know just what routine to go to, and I know where the problem has to be. Now, if I'm writing it as one big routine, and if it turns out that it's several lines long, it could be that it's in here, but it could be something that I did earlier that caused a problem in here. So there really are good reasons for modularizing your code, for taking your code and breaking it up into methods or functions. All right. Now, there's a few things about this that they'll mention here. The first thing they're going to talk about is an access modifier. And believe it or not, especially in the GUI or Windows apps programs that you've used so far, you've used these. Virtually everything we put in there, we've used and made private. Make something private. What you're saying is it belongs in the class and no one outside of the class can use it directly. I want to say that again. When you make something private, all right, then the file basically that you're in, the class file, can access that thing, but outside of that file, it can't be accessed, or at least not accessed directly. If you want to be able to create something in one file, class, whatever, and have it be accessible in another, you make it public. All right. And you're going to see this as we go on. There's actually a few other things that you can use other public and private. They're not going to make a boatload of sense right now. They'll make more sense when we get to chapter 12. And we talk about things like protected and internal, etc. But for right now, they probably wouldn't make a lot of sense. I don't want to burden them with you right now. All right. Okay. Now, sometimes when you create a method, it returns a value. We've done this before as an example. I've done programs where I've used that keep going variable and we validate a field and we return a Boolean value of true if the check did work and false if it did not work. All right. So in other words, that's a return statement. If you return nothing, you basically set the return type to void. But the return type that you set, all right, that return type must match whatever, if you are returning something. So if I'm returning an int, then the return type must be an int, that type of thing. Now they go through this and they say that a common coding convention is to start each method name with a verb. That's not a bad idea. What that does to, in most people's opinion, is that it makes your program a little bit more English-like. All right. Okay. Then after you put the name of the method, you put a set of parentheses. Within those parentheses, you declare what that method needs in order to do its thing. Now, imagine this. I've given this example before, and maybe it's a good one, maybe it's not, but I'm going to anyway. All right. So imagine that, I mean, my kids are all up and grown and out of the house, but imagine that they were still in the house. And I walked into the, got home from work, walked into one of their bedrooms, and it was just a pig pen. And then they came home from work and I was not happy. And I said, clean the room. All right. Basically, that's what I wanted to tell them. All right. And they come back in their typical Weisheimer type of way and say, what room? All right. And I'll put in here your bedroom. So clean the room would be the name of the method. Your bedroom would be the name of the parameter. This probably would be private, and it probably would return nothing. So inside of here, I would have whatever needed to be done. I'm just going to put dot, dot, oops, dot, dot, dot. It doesn't matter. All right. But that whole thing in there is how you would set up a method. Now, what's one of the really important things about a method is, really, there's 4 pieces in here. This is called the access specifier. So it's private, so it can only be used within this file or within this class. This means it doesn't return anything. So it's its return type. This is the name of the method. And this is the parameter that the method needs. Parameters are also called arguments. Sometimes you can write a method that has no parameters. Sometimes you write a method that has one parameter like this. Sometimes you write a parameter that has multiple. You write a method that has multiple parameters. All right. But one of the things that you're going to see later is this basically right here, this thing that I'm putting in blue. That's typically referred to as a method signature. And you might say, who cares? It's important. I'm going to show you something now that we're not going to really get into right now, but I just want to, all right? So I'm going to change this and I'm going to say private int add to numbers. And I'm going to pass in int n1 and int n2. And all this is going to do is it's going to return n1 plus n2. So why am I showing you this? All right, let me come down and copy this again. Now I'm going to make this a decimal. And what I'm telling you right here is what I've done in the second example is I've done what's called overloading a method. You can do this in a program. You can have two methods with the same name, but their parameter lists must be different. All right, so in this first case, I'm passing in two integers and I'm returning an integer. In the second case, I'm passing in two decimal values and I'm returning a decimal. That becomes really important later, but I wanted you to at least see this in action and let you know again that collectively this, some books will say this, but most will just say this, is what's known as the method's signature. And it's the name and the parameters, all right, that the system needs. Now, had we done this, let's just say we had done this and this. That wouldn't work because the parameter lists are the same in here. So you cannot do that. All right. Okay. And again, this is called overloading a method. And I bring it up because they bring it up in here. All right. It says later in this book, you'll learn how to create two or more methods with the same name but different parameters. This is known as overloading a method. So I just showed it to you. All right. So virtually all of the methods that we have done so far have been private. Okay. If I need to share information between whatever I'm working on and maybe whatever somebody else is working on, I might have to make something public. All right, so you saw that for right now, private is fine. Then our return type, then the name of our method, and then the parameter list. And you'll notice in here that public private is in curly braces, meaning it should be one of those two for what we're doing now. And you'll notice that parameter list is in brackets, meaning, again, not mandatory. Here's an example of no parameters. There's no return type, so the return type is set to void. Here we're returning a value. The value we're returning is a decimal, so our return type must be decimal. Now, the way that this is set up by default, which basically means unless told otherwise, you can only return one thing from a method. I want to say that again. By default, you can only return one thing from a method. You might say, what do you mean thing? Don't you mean value? Sometimes yes, sometimes no. We'll get into some of that in chapter 8 and in later chapters. All right. Here's an example of a parameter that has 1, 2, 3. I'm sorry, it's a method with 1, 2, 3 parameters. But notice it's only returning one thing. All right. They kind of go through and through this right here and summarize what I've been talking about right there. All right. So how do you call methods? All right. They, for whatever reason, they're using the word this in here, which doesn't hurt to use that. But you'll notice the word this is again inside of brackets like that, which means it's optional. I don't think I've ever called a method by saying this dot that I remember. Now, in some languages, you would do that. Since it is not mandatory in this language, you don't have to do that. Can you do it? Should you do it? It's a judgment call. To me, it's just kind of superfluous or extraneous code that you don't need. So I don't. All right. But this right here, that's a method call. It's the name of the method. If that method is expecting parameters, you must pass those parameters. All right. And again, now when you pass these things, there's different ways that you can pass them. This is something that the people who wrote this language decided a while ago. I'm not going to say it's a good thing. I'm not going to say it's a bad thing. Right? But it's something they decided to do. All right. And that is, you can typically when you pass these, you pass them by what's called position, and that's what's right here. Whatever value you put in here for the monthly investment, whatever value you put in there, all right, that value inside of this method that's called calculate future value, that will be your monthly investment. Whatever value you put in here inside of calculate future value, that will be the monthly interest rate. And whatever you put in here and calculate future value will be the months, even if you transpose it. So in other words, if I had done something like this, and this is not a great example, but I'll just show you something simple here, okay? And that is if I did this, int x equal 3, int y equals 7. All right, and then we'll say int difference equals diff two numbers, and I'm going to pass them in as x and y. All right, that means that in this routine that's called diff two numbers, it's going to have to return an int. So private int diff two numbers. All right, and I'll just call them int n1 and int n2. All right, and if it's a difference, I can say diff equals n1 minus n2. All right, nothing, there shouldn't be anything surprising there. All right, but what happens when you call a method this way and you pass these parameters? They literally get passed by what's called value. So really, this isn't what gets passed in here. This is what gets passed. Copies of whatever is in X and whatever is in Y get put in there. All right. So if I came in here and if for some dumb reason, I would come in here and say N1 equals 100, N2 equals 55. And then I said diff equals N1 minus N2. And I said here, return diff, it literally, in fact, now that I need to put in here int diff, it literally would return 55 here, or 45, I guess, because I'm working with copies. All right. What if I'm working with it and I don't want to be able to change those values? All right, we're going to look at that in just a couple minutes because you can do that too. And there's different ways that you can do some of this stuff. All right. All right. Now there's optional parameters. Let's pretend for a second that I have been asked to write some kind of a program for Rankin Technical College. And if you remember that stuff that we looked at before, name, address, city, state, zip, etc., we had about 8 values. And let's say that I am told that 90+% of the students that go to Rankin Technical College are from Missouri. All right, then what I might want to do is I might want to do something that sort of looks like this, but I would say string state equals double quote Missouri double quote. All right, which means that if I don't pass in a state, it will default to Missouri. All right, so in this example that they're showing right here, we've got 3 parameters. The monthly investment is not an optional parameter. You must pass in that. But you'll notice that the interest rate and the months are both optional parameters. What that means is if I call calculate future value and I only pass in a single decimal value, let's say 1000 M. All right, if I pass that in, then the interest rate will automatically be set to 5% and the months will be set to 12. So I can call this routine in one of 3 ways. I can pass one value in and use optionals for both. I can put in 2 values, so I could put in my own interest rate, but leave off the months and it would default to 12, or I can override what's in both of these, pass in my own monthly investment, my own monthly interest rate, and my own number of months. So there's 3 different ways here that this can be called. If you ever decide to use optional parameters, as they show here, they must go at the end. All right, they must be the last thing that's in there because they're optional. All right, so there's different ways that this can be used, and at times at least, this is a really nice thing to have. All right, and as they said, you can combine by passing arguments, some by position and others by name. All right, and with name, they've got that in here too. Notice what we're doing here. Monthly investment, monthly investment, months, months, monthly investment, . Why would you ever do this? This is called passing parameters by name. Because if you pass by name, you don't have to put them in their right order. You can put them in any order you want. In fact, if I were to call this and pass in all 3 values, remember there were 3 things in here. There was a monthly investment, a monthly interest rate, and a months. So let's say I don't want to use any of these default or optional parameters. But if I put in there months, months, comma, monthly investment, monthly investment, comma, monthly interest rate, monthly interest rate, I could pass them in that order. And the system would know what to associate with what. I don't think I've ever used that, but depending on your point of view, that can be a nice thing, depending, like I said, depending on how you're going to use it. All right. The next thing that they do here is they start to get into expression bodied methods. We've looked at a little bit of these before, not much, but a little bit. And as it says, these expression bodied methods use what is called or referred to as the lambda operator, which is an equal sign followed immediately by a greater than sign. All right. And as it says, an expression bodied method can return the value of an expression or execute a single statement. This is even important, should you care. All right. So what they're showing here is you can do it kind of like this, which is totally fine. This is kind of what we were just looking at. Private, void. All right, so private, the access modifier, void, the return type, display error message, which is the name of the routine, string message, which gets passed in, string caption, which gets passed in, and then do a message box. Totally fine. All right. Or you can do it like this, which looks very similar. All right, but you'll notice that the curly braces are gone. The curly braces have been replaced with the lambda operator. All right. The reason that I believe, at least, that the authors put this in, talk about it, etc., is that many programming languages are moving to this. All right. When you take the AWD1100 class and the AWD1115 class, which are the second year classes, you do a lot of work with the lambda operator. That doesn't mean that in this class you ever have to use it. But if you prefer that, you can do it that way. In fact, they don't show it here, probably because there's not enough room. But what they show right here, let me just copy this. And we'll put it up here. All right. So what they have here is something that looks kind of like this. But if you notice when I did it, and let's make this a little smaller. If it's just one line like this, you can put everything on the same line. So to some people, at least, this looks a little crisper, cleaner than doing it the other way. So it would be this. All right. And let's come in here. As opposed to, all right, coming in here and then doing this. All right, they're doing the same thing is what I'm telling you. So you could use either way of doing this. All right. Okay. And as it says we'll talk a little bit more about it in chapter 12. In fact, not just chapter 12. When we are near the end of the course here, we're in chapter 18, we're going to have a whole chapter that's going to be on something called linked, LINQ. It's way off in the future. Don't worry about it right now. But we'll be using the lambda operator in there a lot. Okay? All right. So now they talk about refactoring, and they mentioned this earlier in the book, but let's just talk about what you do here. They've highlighted the code that you can see in mustard yellow right there. And they've decided that rather than being inside of our button calculate, they want to put that into its own method. So what they do is they highlight the code they want, and then they use the combination of control plus. So hold down on the control key, hit the period key, and then select extract method. When you do that, it takes this and it makes it into its own method for you. All right, that's refactoring. When you refactor, typically when you refactor, all right, you're taking something that was pretty big and you're breaking it up into multiple pieces. All right, you don't typically refactor the other way. All right, okay. Okay, now they're going to talk about reference and they're going to talk about value. Okay, and I want you to understand the difference. You're going to see some differences in just a bit, but I want to show you quickly the difference between these. All right. If I were to come in here and do this, I'm going to go basically show you an example that's going to be very similar to the one I've just shown you. Make this bigger here. All right, so if I come through here and I say int x equal 3, I think this is what we did before, int y equals 7. All right, then we say int, let's do the sum this time. We'll say sum equals add 2, and we'll pass in x and we'll pass in y. Then down here later, we'll have private int add 2. We can call these, we don't have to call them x and y. So we'll call them n1 and we'll call them n2. All right, we could call them x and y. It doesn't hurt anything to do that. So I'm going to say return n1 plus n2. Why am I even showing you this? All right, I'm showing you this for this reason, okay? That what is happening in here, these two values get passed by what are called value, which means copies are passed, which means what actually gets passed is this and this. That's actually what happens. You don't pass actually X, you don't pass actually Y, you pass a copy of X and you pass a copy of Y. And you might say, that's fine, who cares? Sum is going to be 10 regardless. That's true. All right. But what if I wanted to do this differently? Okay, what do I mean? Well, I'm going to create sum right here and just do it like that. I'm not going to give it a value. Now I'm going to call add 2 and I'm going to pass in x and I'm going to pass in y. I'm going to pass in sum. But I want the value of sum to actually change. I want to say this again. All right, I'm passing in a copy of x and a copy of y, but I want sum to actually change. So now I'm going to put in here the word ref, and I'm going to put in here sum. All right, and in here I'll put in ref. We'll call it the same thing, okay? And I'm just going to say sum equals. Now, I could have given a different name. We could call it S or whatever. It doesn't matter. The difference is when I create this right here, when I create that, somewhere in the memory of the computer, I don't care where, let's just say it's at address 1000. What actually gets put there is something that looks like this. 000000011. All right. And when I put this in here, and I'm going to explain all this in just a second. All right. So let's say this is at address, I don't know, 1650. Okay. And this is going to be 000000111. What is this? What the heck is this? This basically is machine language. This is how many ones there are. This is how many twos there are. There's 1, 1, and there's 1, 2. All right. 1 plus 2 is 3. This is how many ones there are. This is how many twos there are. You keep doubling it. This is how many fours there are. So 1 plus 2 plus is 7. Okay. What I'm telling you, though, is this and this do not get passed. They do not get passed. What gets passed basically is this and this. However, when I've got some here, now let's say that's an address 2200. There's whatever garbage happened to be in there before. It's not, it could be 0, probably is, but let's say it's 0. So 000000000. All right. So what I'm telling you is when we call this, what gets passed is this for X, this for Y, this for some. When you pass an address of something, any change you make is a permanent change. If I had come in here and done this, if I had come in there and said N1 equals 17, N2 equals 23, it would have added 17 and 23. All right. And it would have returned that. So if I'm going to return some, all right, I don't have to, but some is 40. It is 40, even though it's 3 and 7. But these values aren't changing because these are just copies I'm passing in. You shouldn't play with copies like this. You can, there's typically not a reason to do it, but it can be done. This is, since it's an address, all right, you're passing in an address, so any change you make is permanent. It's a permanent change. If you still are confused, think about it this way. If I am at Rankin Technical College, where I lecture from on Mondays and Thursdays, all right, so if I'm in there, I am at 755 Parr Road, all right, and actually the building that we're in right there, it's called the Larry Elms Training Center. Rankin does not own it. Rankin rents that building. All right. Let's suppose that Rankin decided they were going to build another building next to where the other building currently is, and we don't need the Larry Elms Training Center anymore. So Rankin moves out, and let's say somebody else moves in. Let's say a fast food place, doesn't matter, a McDonald's. All right. Well, the address is still 755 Parr Road. It doesn't matter that the contents have changed. The address remains the same. So any change that you make with a ref is going to be a permanent change, because rather than passing in copies of the values, you are passing the address of where that thing is. And you're going to see examples of this. So if it doesn't make a lot of sense, it really is okay. Ref is short for reference, just so you know that. All right. Now, they do mention in here, you can use ref, you can use out, and you can use in. All right. And what's the difference between them? I'm going to show you some of the stuff later, but look at it this way. Okay. When you pass something as ref, you're passing the address. When you pass something as out, you make it write only. You can't read it, you can only write it. If you pass something within, it's read only. So going back to the example we looked at before, had we gone in and passed this and said here in, we would have had to have included it here. And I forgot to put the int in there. Now, if we tried doing something like this, we would have gotten an error, because when something is passed in as an in parameter, it's read only, which means you can't change its value. So if we tried to do that, we'd get an error message. All right, so that is a protective type of measure right there. All right. And again, I'm giving you the stuff here. It's all in the book. So they've got an out and a ref are very similar to one another. All right. The difference is when you use ref, you're passing in an address. When you use out, you're not passing in an address, but you're not passing in a copy. You're passing in something that's write only. They're used in a very similar way. I'm going to show you an example later. And when I show you that example later, all right, what you're going to see is just exactly how similar they are one to one another. Now, if we create our programs and we choose, for example, Windows Forms app .NET Framework, we can't do this because we're not using 7.0. We're using 4.8.2. So the stuff they talk about in here, you can't use. So if you want to be able to use the stuff in here that they say with 7.0 and later, and if you have loaded 8 like I have, then rather than Windows Forms app .NET Framework and rather than console app .NET Framework, you've got to use the regular Windows Forms app or the regular console app without the .NET Framework. Okay. All right. This thing with tuples, I'm going to keep it short and sweet. When you create a tuple, what you can do is you can create something that has multiple values. So notice person has both a name and an age. You can refer to the name with person.name and the age with person.age. All right. Why should you care? You should care because what you can do is you can also return a tuple. So even though it's one thing, so again, imagine if we had person and we had what we talked about before. So if we created it as a tuple and we had a string for the first name, a string for the last name, a string for the address, a string for the city, etc., we could make that into a tuple where it's looked at as one variable that kind of has 8 pieces, and then we could go and work with all 8 pieces collectively. And that's all I want to say about those. Again, I don't use them. I find them a little bit confusing, and especially considering that this is an introductory class. Go ahead and read it if you understand it, if you want to use it. I'm not going to recommend that you do that, though. All right. Now, the next thing, believe it or not, much of the stuff that's in here, and I'm going to go about 12 more minutes. We'll take a break right around 9 o'clock. All right. So events and delegates, we've actually done a lot of this already. You probably don't realize that, but we have. And you're going to see further examples as we go on. Now, let's assume if you look in here, I'm going to use an example. This is very similar to one that's going to be an example in the book in just a bit. So we have it here, monthly investment. We've got yearly interest rate. We've got number of years, and we've got future value. Okay. Let's assume you can see by looking at this, not assuming, but you can tell by looking at this that future value is a read-only field. You can see that the text box is gray. All right. If we want to set it up so that anytime we change whatever is in here or whatever is in here or whatever is in here, so anytime we change any of the 3 text boxes where we can put information, if we want this to clear out, we can write one routine and call it from each one of these places to make that clear. That's one of the things you're asked to do in the extra exercises that we'll look at tomorrow. All right. So how do you do that? Well, so far, the only thing we've really been double clicking on has been buttons, and you get a click event. If you double click on the form itself, you get a form load event. If I double clicked on each one of these right here, I'd get what's called a text changed event. But as you can see right here, down here, if you look at where my mouse is, I'm whipping the mouse around here. It's calling clear future value. So if I do it for the text changed event, if I call clear future value from there and from there and from there, and in that routine, all I say is txt future value dot text equal double quote. That means that anytime I click in here and make a change, or in here and make a change, or in here and make a change, this will automatically clear. So what we're doing is we are using one method for 3 different events: a text changed event for our monthly investment, a text changed event for our yearly interest rate, and a text changed event for our number of years. Every control you put on a form has different events that you can write code for and that the program will respond to. Now, I'm just going to bring up something. We're going to look at it later, so don't worry about it. It's a very, believe it or not, one of the examples I put in here is a very simple example. Where do I have it here? I think it's here. Yeah. All right, we're going to have this, and we've looked at something like this already. All right, like I said, it's going to be a very simple routine, but you'll understand, hopefully, why we're doing it like this a little bit later. So this is just basically a program that will say whether or not you can vote. That's it. All right, and I wrote 2 versions of it because part of it will talk about what we do in chapter 7, but this is the first version. All right, why am I even showing you this? Okay, no, I'm not showing you this to waste your time. But if I click on here, if I double click, that's going to bring up the click event for the calculate button. That shouldn't be anything new. But what you may or may not have realized is if I click on the calculate button and I go up over here, I'm going to bring this way up so you can see it. All right. If I click over here where it shows the lightning bolt, now it's telling me right now, the only routine that I have in there is my buttons calculate event. But notice there's a bunch of other events in here, probably 30 events, 25 to 30 events. I could put code under any of those. And just to show you what I mean, all right, I'm going to come back and I'm going to click on this. This is the text box. All right. And I'm going to go in my click event for the text box. In fact, we'll do it here just to show it to you. But I'm going to come in here and I'm going to call something. And it doesn't have to be called the name of the text box underscore click. I'm just going to call this say hello. Okay, and hit enter. Notice what it does. It creates a brand new routine for me called say hello. So I'm going to say message box dot show hello. This is your greeting. All right, a dumb example, but I just want you to see this. Now, when I run this program, I don't know why it's taken that long, but it is. Give me errors. Let's see what the errors are. It's telling me it doesn't like something. It must be what I just put in. Let's see. Process cannot access the file. Oh, I'm sorry. It's because I opened it before class. I've got it open right here. So let me just close that. That was why we got the error. It has nothing to do with the code I put in. Let me go back and run the program again. It should run now. There it is. Now notice what happens when I click. I get this. This is your greeting, hello, because I put code in the click event. So every time I click here, all right, that's going to run. Okay. Now let's do one more in here just so you see it. This will be very irritating and it might not work the way I want it to, but we'll see anyway. And that is, I'm going to put in here. In fact, let's use, I don't know, we'll use mouse enter, I think is one that we can use in here. Okay. So I'm going to call this say goodbye and hit enter. All right. And I'll copy this in. Okay. And I'm going to say goodbye. This is your parting. Now, before I run this, and I'm going to in just a second, but before I do, I don't want this one anymore. All right. I want this line, but I don't want this code anymore. Do not come in and just hit delete. Don't do that. We've talked about this before. If you don't want it, go back into here, find where it says say hello, get rid of it there, highlight it and get rid of it. You'll notice it's now, well, it should have been gone. Now we can remove it, though it won't hurt anything. All right. But what I'm going to do is I put this code that I just showed you in I think it was in our mouse enter event. All right. Yes. Now I'm going to put this in our mouse leave event. Okay. In fact, I probably have reversed it, but it doesn't matter. So we'll have this say hello in here. All right. And I'm going to paste that line back in. Now watch what happens. Okay. This gets very irritating, but notice when I put my mouse in there, it says hello. And when I leave, it says goodbye. All right. So why does this matter? All I'm trying to show you is that you can put code in other events than just a click event. And that's really all I'm trying to show you here. And you can put events in other things other than, all right, I'm going to remove these. You can put things in events other than buttons. All right, you can put code in almost any control that exists. One last thing to show you here. It's almost break time, but one last thing to show you. All right, I'm going to go and double click on my form. And it brings up the form's load event. And I'm going to put in here another message box. And it's just going to say, hello, welcome to my program. Something like that. This is a little weird. I'm going to save this and run it. And this runs even before it shows my form, because the form, this gets called right before the form gets loaded into memory. So welcome to my program, hello, and now it shows it. All right, so again, all I am trying to show you here is there are quite a few places in your code, if you so desire, that you can come in and you can add code. All right. Was a little longer than I planned, but I wanted you to see this. They do talk about it in the text. All right, so I think we've kind of hit this and covered it, I think at least. When we do this, it is doing event wiring. It is adding lines like this to that form designer file. And that's one of those files that I told you you should not go jacking with. This is what we called it. This is what the system refers to it as. So we're basically saying, take this and assign it to this. And again, do you have to worry about that? Technically, no, not at all. All right. And again, you could handle multiple events with one error handler. That's what I showed you before, where we would go in and call clear future value from multiple places, like we do right there. All right. Now, this is a good time. It's 8:59. We're going to take a break. When we come back, we only have about 4 or 5 pages left in this chapter. We're going to go over, and as they show here, we're going to look at another version of the future value app. In fact, I think there's about one, two, three, four, yeah, 5 more pages. All right, I could do it before we break. Let's just take a break right now. It is 9 o'clock. Let's just take 10, okay? And come back at 9:10. We'll finish this up and jump right into chapter 7. right, I think it's 9:10, and that's when we said we'd start back up. Two things as we get going here before we get back into this. The first is I made this. I sent everybody out an email with this information, so you should have gotten it already. It's got Jacob. I don't know if it's Weinreich or Weinrich. I don't know, but you can see his information. So feel free to contact him. You have to work around his schedule. He does not have to work around yours. That might not be fair, but that's just the way it's always been around here. So that's the first thing. And also, just so you know, in a couple minutes, we're going to be looking at some examples of a calculator program. And I was going to rewrite them from scratch, but they're almost all the same thing. So I put it out there already as a GitHub repository. All right. So it's out there. And by the end of the period, there'll be another one out there. I hope that's going to be like this, but it'll be called Can I Vote? So those should be, and I'll put those out there again later too. All right, but those should be what we're working on for the rest of the period. So the chapter ends with another version of this future value app. All right, and as it says in here, it says the next figure shows the event handlers. All right, so let's take a look at those. And you'll notice that we've got a thing in here that's called clear future value. And all that is supposed to be doing is clearing out that last text box like we saw before. I don't know if it's still up here or not. Probably, no, it's not. But we looked at the picture of it before, okay? And this routine can be called from any place, all right? It's just all you're calling is clear future value. But where you end up calling this from is from all three of the text boxes. All right. Now, they're talking modularization here. I've been trying to modularize for quite a while because I knew it was coming and I figured why not just do it the right way to begin with? As they say here, this calculate future value method does modularization. It separates the calculation from the rest of the code. Finally, the text changed event for monthly investment for yearly interest rate and number of years is going to be wired to this clear future value event. All right. And that just means that when you change anything in any of the first three text boxes, what goes into the last text box is going to automatically change. All right. By clearing out. All right. Now they talk about a little bit of stuff here that we really haven't talked about before. So let's take a quick look at what's on this page. It says here, the next figure shows a partial listing of the code for this application. To start, and you may or may not have noticed this, but at the top of when you write a Windows Forms app or a GUI app, you have this initialize component method. As it says, that creates the objects. It basically goes out and does a communication between your file and that designer file. And it builds everything up on the screen. So it builds your GUI. All right. So as it says, it creates the objects from the control classes and assigns them to the associated variables, which you've already declared. All right. Next, it says it includes a group of statements for each control. All right. Starting property. So whatever you've wired in, we've wired in things like what? Accept button, cancel button, tab order, etc. All right, it says the last statement in each group wires an event to an event handler. The click event is wired to the BTN calculate click. The text changed event for the text boxes call the clear future value. All right. Now, they do mention in here, and I've said this to you, since this is going to be working with that designer file, as it says, you should avoid modifying code in that designer file because it's a real easy way to get your program, for lack of better words, stuck. All right. And it may be nearly impossible to get it out. Now, years ago, we're not going to do this in here, but years ago, when I was teaching this class, one of the things that we wrote was we wrote an application for a thing called Joe's Auto Sale. And the dumb instructor for the class, meaning me, should have told the people to call this Joe's Auto Sales. But what a lot of people did was they called theirs Joe's Auto Sales. And guess what? It worked just fine until it didn't. And it had to do with the fact that this was in there and that these were in there. And the program seemed to work fine, but one day it just stopped working. And at that time, we were working with an earlier version of the software that if you had given it this name, you could not go back and rename it. So people would say to me, what do I do? And I said, well, keep your code, create a new project, and just copy the code in. No, really, what do I do? That's about all you can do. All right. So bad things can happen, still can happen, if you go in and you play with that form designer code. All right. So they show you, again, that's what's in here. It's in the designer.cs file. So here it's wiring up the button to the click event. Here it's wiring up clear future value to the text change event here and to the text changed event here. All right. So a lot of this stuff is happening to you, for you, but it's happening behind the scenes, so to speak. All right. Just so you're aware of that. All right. Now we're going to go on in just a moment, but before we do, we're going to go on into chapter 7. But before we do, I'm going to bring up this thing, and I called it Calculator Many. I don't know why, but I did. And this is 4 different ones. This last one I didn't finish, so it's empty. But I'm going to bring this up. These are console apps. And for whatever reason, some of you in this class are just, you can't wrap your head around the fact that the only difference between a console app and a GUI app is a console app only has code. It doesn't have any actual controls. But the logic in a console app is virtually identical to the logic that you'd put into a GUI app. You don't have write and write lines, all right, but you're doing the same logic. Okay, so I'm going to bring this first one up here. Let me get rid of these. And I'm going to just take these from the top. We'll spend 5 or 10 minutes, hopefully, and that's it on these. So I'm going to go back to the first one. I'm going to set my startup project, and I'm going to bring this up. Now, what I have here is probably the worst way of writing this. That said, it's pretty much the way we've been doing it so far. What do I mean? Well, we're declaring all these variables. So I could put my comment there that says declare and initialize class variables. Okay? All of these variables that are in here are being defined outside of any method. What's a method? Main's a method. Input num1 is a method. Input num2 is a method. Calculate sum is a method. Calculate diff is a method. Calculate prod is a method. Calculate quote is a method. Calculate mod or the modulo is a method. And show results. These are all methods. The bad thing, so to speak, about declaring your variables here is those 2 nasty words that I mentioned in an earlier lecture. They are side effects. What that means is, since these have been defined as class variables, even though I'm setting the value for number 1 here, even though I'm setting the value for number 2 here, even though I'm doing that, I could come into any one of these and change the value. I could come in here and say number 1 equals 100, something like that. What is it? It's num1, I think, isn't it? Where is it? Num1. So I could do this and say num1 equals 100. I don't get an error. I'm going to comment this line out. All right. But everything that's in here, everything, these are all global to the program. All right. I put it into a while loop and I just said while 1 equal 1, and I'm calling everything. Clear the screen, input the first number, add the two numbers, subtract the second from the first, multiply them, try to divide them, but I do check for divide by 0 and do the modulo and then show the results. Okay, hopefully that's pretty straightforward. So we come in here in the input num1. I did do an int.parse, so if it doesn't work, we give you an error and we call it again. All right, let's just run this. So 4567. And there you go. 45 plus 67, 45 minus 67, 45 times 67, 45 divided by 67, and 45 modulo 67. All seems to work fine. Now, to show you again the benefit or non-benefit of a side effect, I'm going to come in here for the diff, and I'm going to say num1 equals 723, num2 equal 456. Okay, I'm making no other changes. And I'm going to say file, save all. Run the program again. Okay. It doesn't matter really what I put in here. Let's just put in something everybody recognize. So let's put in here 8 and 2. And notice what I get. I magically changed every one of those. I did a side effect. And you might even say, wait a minute, you changed it in here. Why did they all change? Because what I'm doing down here is I'm printing the results at the end. So they have both been changed. Now, you might say, well, it's okay. They gave you the right answers. And that's true. But they gave me the right answers for 723 and 46, except that one ain't right. That grabbed 8 and 2. So in other words, I'm going to do this one more time. I'm going to grab these things right there. And this is probably the worst example, but just to show you. All right, I'm going to come in here and in my show results, now I'm putting that in. All right, so do a file, save all. Let's run it again. Let's again put in 8 and 2. Now look what you get. All right, I guess it's still giving me the same stuff. I'm surprised. All right. So let's see, did I remove it from here? No, I did not. That's why. So let me remove that. So file, save all, 8 and 2. All right. Now, none of those are correct. Why? Because it's using 8 and it's using 2. I had a non-wanted side effect by going into a routine where I shouldn't have changed anything, and I changed it. All right. And everything, as you can see, was affected by that. All right. That's why side effects can be a good thing and they can be a bad thing as well. All right. So that's the first example. Hopefully, at least you found that pretty simple. I did come in here again, enter an integer. If it doesn't parse to an integer, call it again. And I did that with both of them. All right. Then to calculate the sum, just add the two, diff, subtract, prod, multiply. For the quote, check if it's 0, say illegal divide. All right. Otherwise, do the divide. So what you'll see is if I run this again and I put in 34 and 0, all right, I get illegal divide and illegal mod divide. If I didn't put those in, I'd get what we're going to talk about in a few minutes in chapter 7, and that's what's referred to as a divide by 0 exception. Just to show you that, all right, let's take these this code right here. I'm just going to comment it out for right now. All right, I'm going to run this again, and 34 and 0. The program blows up, and it says you attempt to divide by 0. That's what I just did attempt to do. We're going to figure out how to fix these in the next chapter. This is one way of fixing them. We're going to look at yet another way of fixing them, all right, in the next chapter. So that's the first example of this. All right, that's the first example. Let's go and let's look at the second one. So let me uncomment that. Oops, not that way. Let me uncomment that. There we go. One more. There we are. All right, and we'll bring up the second one. So let me close this. I don't need to save, and we'll bring up the second one. All right, notice how it's changed. All variables are local. What does that mean? Well, now in here, I've got this thing, so don't worry about that. That's just going to give you those messages that you saw before. But in here now, okay, everything is being declared inside of the program. Inside of main, I create num1, num2, sum, diff, quote, and mod. And since I'm creating them in main, which is a method, all right, when I want to use them in other methods, I have to pass them to the other methods. Now notice what I did in here. These are both calling the same routine. They're calling input number. And by passing in the number 1 and the number 2 in there, by passing those in as parameters, I'm letting it know that the number that I input, I want it to go in here, or that the number I input, I want it to go in here. So rather than, as I did in the first example, rather than writing one routine, just one routine, or that's what I'm doing now, is writing just one routine that's being used for both. Previously, I wrote one that was called input number 1 and another one that was called input number 2. All right. But I need a way for the system to be able to differentiate between the two. That is 1 or 2, which I called in here the number. So if the number equal 1, call it for number 1. Otherwise, if the number equal 2, call it for number 2. All right. And you'll notice that I'm passing parameters. So I'm literally passing two ints in here, an int and an int. So I need an int here. Here I am passing two ints here and here and here and here and here. This is the first number I read in, second number I read in. Num1 and num2. These are called actual parameters. That is, num1 and num2 are their actual names. In here, I called them num1 and num2 again, but I could have changed all these to like n1 and n2 or number 1 and number 2 or whatever. Inside of the routine, these are called formal parameters. All right. I don't know why they use those names, but somebody came up with them. All right. But you'll notice now I'm passing things in. The program works just the same as it did before. So if I said a startup project, number 2, run this, it's going to look just like it did before. 8 and 2, there it is. And again, if I do run it and I put in, all right, I get my illegal divide and my illegal mod divide. All right. So that's the second example out of the 4 I want to show you. All right. So let's go up to the third. And I'm going to make that my startup project, and let's bring that up. All right, it looks very similar to the last one, except notice that now I am not taking the answer and saying sum equal calculate sum, diff equal calculate diff. I'm not doing that. All right, rather I'm passing sum, diff, prod, quote, and mod in as ref parameters. And as I mentioned to you earlier, when you use a ref parameter like that, all right, a ref, what that's going to do is it's going to pass in the address. So I am permanently changing the value that gets put into sum, diff, prod, quote, and mod. But notice at the end, there is no word ref because I'm not changing their values. So I'm passing copies. And you'll notice that I have to say ref here, and I have to say ref here. It's just the way it works in this language. But again, it'll look exactly the same. I literally did a bunch of copy and paste when I was doing this. So again, if I run it again, oh, I had the value of in there. So, okay, still works. Finally, if we look at it one last time, so let me make that the active project by choosing set as startup project. And let's bring this one up. Basically, all I did in here was I replaced the word ref with the word out. Other than that, it is the same program. And again, out means that it's write only. All right. Still works just the same. All right. So you've got all of those. And I will again, I will give you the address to that. All right. Now, what I'm going to do next, before we are going to jump right into chapter 7 in probably about 10 or 15 minutes, because what I want to do first in here, what I want to do first is I'm going to write a very simple program for you, and I'm going to write it twice. All right. So let's take this and just close this. Okay. And I've got this folder that I just put in here called Can I Vote? To start up, I'm going to start up my program or Visual Studio, a new version of Visual Studio. There's a reason I'm doing this. You might think, well, if it's so simple, why are you writing it? Because we're going to write it, then we're going to go over chapter 7, then we're going to rewrite the program again. And we're going to replace a lot of the if statements that we have in here with what we learn in chapter 7, which are called try-catch statements. We're going to learn what's called exception handling. All right, so I'm going to come in here, and it's going to be a Windows Forms app.NET framework, and I'm going to call this Can I Vote If Statements. Kind of a dumb name, but it pretty much shows what it is. So here, there's Can I Vote. All right, so I'm going to just call this, I'm going to change the name of my solution to just Can I Vote, like that, and click Create. This is my simple interface, and it's going to be simple. I'm going to make my changes I always make. So I'm going to call this, I'm going to rename my form, FRM, Can I Vote If Statements? Yes. I'm going to change the code or the text that's in here to Can I Vote Dash If Statements? All right, which of course changes that up here. All right, I'm going to change my background color and very quickly build the form because this is such a simplistic form. All right, I am going to have here 3 buttons. It's way too big. About right. All right. Like I said, this is a fairly simplistic interface here. Move that up, and I'm going to move that up. And I'm going to have a couple labels. right? And I'm going to have a text box. Okay. All right. All stuff you've seen many times before. But this is going to say, I'm going to call this LBL input age. And that's exactly what it's going to say here is input age. All right. This isn't going to have anything in it. And it's going to be called LBL result. This will be called TXT input age. This will be our calculate button. This will be our clear button. This will be our exit button. All right, center this. Center these two. All right, set the tab order. That'll be 0, 1, 2, 3, 4, 5. And finally, set my default location to center screen. Set my accept button to BTN calculate. Set my cancel button to BTN clear. All right. So far, it's like this is nothing new that you might think is, yeah, this is really a dumb program. Bear with me if you would. All right. So for my exit, I think I saved this from before. Yep, I've got it right there. All right, for my clear is going to be just clearing the form. I think it's 3 lines. It's TXT. Oh, did I not change that name? Let's check. TXT input H. No, I put TX. Yeah, I did. TXT input H. All right. So let's go back. All right. TXT input age dot text equals nothing. LBL result dot text equals nothing. That's what I called it. We'll find out in just a second. And TXT input age dot focus. All right, let's see what I call that. I spelled result incorrectly, so let's fix that. All right. There we go. Okay, so all that's done. I can remove this, save it, run it. The calculate isn't done yet, of course. We know that, so I don't want to do anything with that, but I can put junk in here. I can clear them there. I can exit. Okay, so far everything works. All right, so why am I even showing you all this stuff? Because what I want to show you, and much of it is going to be review from what we've already done, is there are 3 ways that you can handle errors in a program. I have mentioned this before, but I'm saying it again. The first way to handle errors in a program is to do nothing. And suppose that the person running the program knows what the heck they're doing. As you can guess, that's the dumbest way of doing things. All right. The second way is what we're going to be doing here, and that's what we have been doing. All right. And that has been what we have been doing is been using if statements and not letting bad data into our system. All right. And in just a couple of minutes, we're going to learn how to use exception handling. So I'm going to come up here. I am going to make 3 constants. And I'm going to have const int min age equal 1, const int max age equals 130. I mean, I thought that was plenty big. In fact, I used 125. I don't know if anybody lives longer than that or not. I don't know. And finally, we'll have const int legal, we'll call it legal V for legal voter. And that's going to be equal to 18. I believe that's the legal voting age in all states. I don't know, but for this program, we're going to expect that. All right. So we're going to go into our calculate. And again, we're going to write this very similarly to what we did yesterday. All right. So I'm going to come in here and I'm going to say bool, keep going, equal, and I'm going to call right away verify age is not empty. I get the error, of course, because we haven't written a routine called verify age is not empty. But now what you should be able to realize is it's private. It must return a bool because we're sticking it into a Boolean variable. There's its name, and it does not require any parameters. All right. So let's go in and we'll write this. They're all going to be very similar to what we did yesterday. So bool retval equal true string, and I just called it age str for age string, equal txt input age dot text dot trim, just like we did yesterday. Now, if age string is equal to nothing, we know that we left it empty. So what are we doing? We're going to call our show error message, which I copied in down here. All right, so we're going to call show error message and just put in a message that says age cannot be empty. That'll be our text. And our title will be nothing in age text box. All right, so we've got that. There's nothing to clear, so we can just set the focus. All right, and we can get the heck out. All right, but we can't just say return. Now you know this. We must return a bool. So we don't want to even return here. We're going to say retval equal false, meaning that age is not empty is false, meaning age is empty. So now we can return retval. All right, again, you saw this yesterday, but now what this means when I run this is if I leave it blank, what's going to happen? You should be able to guess this. It'll bring up a message box right here with the message, and my cursor will go back there. There's the error. There's my cursor. So in other words, the program is doing exactly what I told it to do so far. And we have not let any bad data into the system. All right, so we'll continue on. If keep going, meaning that there was something in there. All right. That's all we know right now is there was something in there. So we verified that that age text box is not empty. Now let's verify that age is numeric. All right. Again, we get the error because we haven't written it yet. So let's write that right below the other one. And notice here I used is not, and here I used is. I mean, that's totally fine. All right. So in here, to verify that the name is, or the age rather, is numeric, very similar again to what we've done before, I'll have my bool ret val equal true. I'm going to have a bool result because I'm just about to do a try parse. Right? And again, I'll have my string age str equal txt input age dot text dot trim, just like we did before. All right. And I'm also going to have here int age right there. Now, it's a big thing, and you may or may not have realized it. We do not have any global variables in here. We are creating our variable local in here. All right. So we do have, or we're going to try to set age. So result equals int dot try parse age string and age. All right. And it either worked or it didn't work. Okay. Now, hopefully, two with the out, this is a write only variable that we declared up here and we're setting here. All right. So if not result, I'm going to steal this from in here because we're doing a lot of the same stuff. Now we want to say age must be numeric. And I'll just put here non-numeric in age text box. Now, I don't want to just do the focus. I want to get out whatever junk is in there. All right, then set the focus ret val equal false. And finally, return ret val. So now, hopefully at least, I have covered it being blank, and I have covered it being non-numeric. Blank, all right, nothing in there. Non-numeric, all right, non-numeric in there. Age must be numeric. So those are both both done rather. So let's go and do the last one, which is we're going to do a range check. Now, if this failed before, we're going to say else return. Again, get the heck out. We had a failure. Now this is going to say if keep going, equal verify age is within range. What does that mean? That means it's between 1 and 125. All right, let's write that one down here. All right, and just like before, in fact, it's very similar, except now think of what we don't have to do. All right, we've already verified that the age, it wasn't age, because if it wasn't, we handle it there, and that should say non-numeric. All right. So I'm going to copy some of this stuff, then I'm going to throw out some of the rest of it. All right. Just so you don't have to keep watching me copy. Now, ret val equal true, sure. All right. Result, no. We don't have to do a check anymore. That'll give us an error here. We'll fix it in a minute. All right. We don't need this. But now we can immediately come in and do this. All right. Now, since I didn't make an age string, probably should have, but since I didn't, I can just say txt input age dot text. All right. In fact, I don't even have to do that. I'm sorry. I'm going to, let me fix this. Okay. I don't have to try to parse it. I don't have to try. It already has been parsed. So guess what? I can do this. What does that do? That literally parses it without checking it. Why? Because I don't have to check it. This just says take whatever's in here and convert it into this. And else in here. But I can be 100% certain that that'll work because I already did the check previously up here. And if it didn't work, I'm never going to get down to this routine anyway. So now this is going to be a range check. So if age is less than min age, or age is greater than max age. All right. Now we have to say that it must be between. It's always nice when you do this to let the user know what the range is. So I'm saying here min age and max age. Oops, don't need those, sorry. And then my comma. And again, I'll clear it out. I'll set my focus and I'll do a return ret val. Okay, so with this, file save all. I'm not gonna, whoops, did something wrong. So let's find out what that was. Argument missing. Oh, put in 2 commas there. You've already seen no input. You've already seen non-numeric. So I'm not going to rerun those. How about 0? Age must be between 1 and 125. I got to change that. I don't want non-numeric. I should say out of range in age text box. We'll fix that in a second. 126. I get an error again. Okay. If I put something within range, now it's doing nothing because I haven't told it to do anything yet. So this must be within here. So I'm going to say out of range value in age text box. Okay. I don't have to run it again. It's just going to change the title. So I go back up to here. All right. My calculate. So I need here an else return. All right. So now if this succeeds, I know it's not empty. If this succeeds, I know it's numeric. All right. And finally, if this succeeds, I know it's within range. So if I get down here, if keep, now I can do my actual calculation. All right. I don't need anything in here anymore with a keep going equal. I can just say determine vote status, which again, I haven't written yet, but we're going to write it in a second. And I know this is a simplistic program. I can put here else return. In my opinion, it's a little bit redundant. Why? Because I'm at the end of the routine. It's going to return anyway. But you can put that in if that makes you feel more comfortable. So this is determine voter status, which now, at least in my opinion, is pretty simple. Okay, so I'm going to come down here. And before my clear, I'll put this in. Private void, it's not returning anything. Determine voter status. All right. And now we're going to determine the status. All right. Again, age, remember that with age, I either have to be passing it back and forth or declare it globally or set it. So I'm just going to reset it again. I'm going to just say int age equals, just like we did before, int dot parse of txt input age dot text. Same exact thing we did before. All right. Now I'm just going to say if age is greater than or equal to legal V, well, then I know you're 18 or older. So I'm going to say LBL result dot text equal, and I should probably be doing more of this. So I'm not done yet. I am going to use some string interpolation here. You don't need the parens as I'm putting them in, but I like to put them in anyway. All right, and I'm going to say at age, you can vote. Okay? Oops, I'm sorry. Else, at that age, you cannot vote. You actually could write this as a line of code. I'm not going to do that now, but we could. We could check it in here and print it out based on that, but I'm going to leave it the way it is. All right, so let's do a file save all on this, run it again. I've already made my check, so you've seen nothing. You've seen non-numeric. Whoops, what the heck happened there? Try that again. So nothing, non-numeric. All right, I'm getting an error. All right, let's figure out why I'm getting the error. All right, and it's because when I did this, where are we? Down here, if keep going, return, else return. So let's see. That's numeric. Let's make sure that we were returning. Red val is true. Red val is false. Return red val. Red val is false. Return red val. Red val is true. Well, that's interesting. It's calling this routine verify that range, even when it shouldn't. So where is that? It is calling this even if it shouldn't. All right, so verify age is numeric, else return. If keep going. All right. So this line right here, okay, this line should not be getting called. Show you a little debugging here. That line should not be getting called if we hit this. So let's see if we're hitting those lines. All right. So I'm going to run the program and I'm going to put in non-numeric, click calculate. It says age must be numeric, and then it's skipping that return and going down to right here. Well, that's interesting. Oh, right there. I have to say keep going equal verify age is numeric, and I didn't do that. I screwed up. Sometimes my screw ups work out good, meaning it's showing you something, or at least attempting to show you something. All right, let's run it one more time. All right, so with nothing in age text box, with non-numeric in age text box, with out of range age value in age text box. If we put in something that's too small, at age 1, you cannot vote, which you probably guess. At age 17, you still cannot vote. All right, when you turn 18, you can vote. If you're 73, you can vote. If you're 125, you can vote. But if you're 126, you're out of range. All right, I should have cleared that too, and I didn't. All right, so in other words, I should come back, and as long as I'm clearing the TXT input, just in case there's some garbage there, I should also come in and say LBL result dot text equals nothing, just so I'm sure there's no garbage in there. Got it there, and I'll put it here as well. So that's the first one. And again, you might say, yeah, it is. And I learned absolutely nothing from that. Well, what we did with that particular example, what we did was we did write an entire program, and for our error checking, what we did with that program is we used if statements. And with if statements, we kept bad data from ever getting into the system. What I've shown you so far is actually the recommended way of doing this. So we're going to learn another way, but it's the non-recommended way of doing it. So why are we showing it to you? Because some people use it anyway. It's not wrong to use it. All right. But what we're going to learn is we're going to go right now into chapter 7 and talk about how to handle exceptions and validate data. All right. So we're going to get an introduction to what are called exceptions. Then we're going to talk about using exception handling. Then we're going to talk about how to validate data. And finally, we look at the future value app with data validation. This right here is pretty important, and we're going to look later on in the course on a better way of writing it than the way they're writing it now. All right, and if you say I don't get it, you will when we get to that point. Again, a fairly short chapter, only about 25 pages. I'll go till 10:15, and then we'll take our next break. All right? Okay, so an exception is an exception to the rule. It's not a good thing. Exceptions can happen in two different ways. The code can find out that there was some kind of an exception. All right. And guess what? You've already seen this. I showed you an example before with that calculator program where I took out the check for dividing by 0. I did a divide by 0 and I got a divide by 0 exception. That is the system throwing exceptions. You can also throw your own exception. What we're going to do after we finish this chapter, so after the break, all right, and after we get done with whatever we got left in the chapter, we're going to rewrite this vote program and we're going to rewrite it, all right? And when we rewrite it, we will use exception handling so you can see the difference between the two. So an exception is an exception to the norm, all right? So it says a well-coded app will catch specific exceptions that might be thrown and handle them. This is known as exception handling. And to do this, we use what's called a try-catch mechanism. And it can have the word finally in it too. We'll go over all that in just a minute. They tell you some of the types of exceptions that you can get, and there are several. If I would go out here and write a list of C# exceptions, I used to have a really good one in here. Maybe this is it. I don't know. Yeah. So there now you say, well, that isn't that many. No, it's an alphabetized list. So again, I don't know how many there are, but then there's some data exceptions, some IO exceptions, etc. Collectively, maybe 100, somewhere between 50 and 100 is what I would guess. All right. All right. So if you want a little more about how it works, again, it's in there. But you've probably seen this at one time or another. All right. And what this is it's coming up with basically the exception handling window. And in here, they show you the type of exception you have, pretty much what it was. So this is the message that goes with it. And there's things that you can do here. The view details will basically show you the value of all the variables and stuff in here. The copy details just means it'll copy it to your clipboard. I've never, the show call stack will show you exactly what's going on. All right, what called what, which called what, which called what to get to where you are. Now, right here on line 12 is where the exception is being thrown. All right, what that typically means is that's where the problem is. Why am I saying what that typically means is? It is possible, in this case, we don't have any code before that, just the curly brace, then the code. And we put something non-numeric in, and that's why we got this error. They put a $sign with 100. That's why you've got this. But it's possible you might have a little bit of code up above sometimes, and then you get the exception here. What this means is It's somewhere between the first line of code and where the exception was called. It should never, ever, ever be afterward. All right, but occasionally that's what happens. Now, this is, as it says, all exceptions are types of the exception class. All right, there are 5 common exceptions. How do you read this? Well, format exception is a type of exception. Arithmetic exception is a type of exception. Overflow exception is a type of arithmetic exception, which is a type of exception. Divide by zero exception is an arithmetic exception, which is a type of exception. All right. So here's some things that could throw exceptions. Well, we tried doing the convert a little bit, but usually I use the parse. Those do the same thing. And notice they throw the same kinds of exceptions. So you can use the convert dot to decimal as opposed to the int dot parse or the int dot try parse, etc. All right, how to display a dialog? Well, when we've been doing this so far, we've been displaying our own error message in here. So when we have an error, we have been displaying the entire error message in there. Nothing new there. What is new is when we go back and we rewrite this can I vote program in just a few minutes. So when we go back and we rewrite it, all right, we're not only going to put in our own error message, we're going to put in the system error message, though. So the error message that gets thrown, the one that gets thrown when we have an exception come up. All right. And if you say, I don't get it, you will. I really and truly believe it. Now, notice they say in chapter 10, you'll learn more about the message box class. You already know that stuff they're going to mention in chapter 10. We've been writing good message boxes all semester. All right. So when you work with exception handling, you do what's called catch an exception. What we're going to end up writing is something that's, all right, let me get rid of all this stuff. Okay, so we're going to come in here and write something like this, try. And in here, just a comment, we're going to put in code that could fail. I'm not saying it will fail, it could fail. All right, and then underneath this, we'll have a catch, and we can put in any of those exceptions we want. We can put in as many exceptions as we want. The only caveat, the only thing here is you must put your most specific exceptions first and your most general exceptions last. What does that mean? I'm going to quickly show you an example. So I'm going to say here, catch arithmetic exception. You can call these whatever you want. This is arithmetic exception, so I call it AE for arithmetic exception. Then in here, you put in your code to handle this exception. Finally, if you have a bunch of them, there's also one, the most general exception of all, believe it or not, is called exception. And I just call that EX. And here's the code to handle this exception. Finally, and you don't ever have to put this in, and that was not meant to be a bad pun, but let me hit enter a few times here and there. You can, what I'm about to put in is optional. All right, and I can come in here and put in finally. This code runs regardless. All right, so you're writing a program. In here, let's say you've got some kind of an error that happens that's an arithmetic exception, something with math. Okay, then what happens is when it hits that line, it's going to throw an exception. If you catch that exception, it'll jump down to here. It'll do this code. One thing you cannot do in any programming language that I know of is there's no go-to where you can say, okay, I fixed you. Go back up here now. That's not how it works. You handle it here, and then you move on. All right. So if you get an error in here that's not an arithmetic exception, but you get an exception, it'll handle it here. Now, if all of this succeeds, you don't do any of this. If something in here fails, you're either going to go in and do this, or you're going to go in and do this. The finally typically is used for what are called housekeeping operations. So if you've got something open, like a database or files, which we haven't talked about yet, you typically close them in there. So you either go right from here and you skip these and you do this, or you go here, something went wrong, and you either do this and go to finally, or you do this and go to finally. And if you can kind of conceive or conceptualize what I just mentioned, that's all there is to it. All right. So here they're showing some examples. If anything goes wrong in here, now they didn't say catch exception EX. They just, this is about the most, pardon my French, piss poor way of doing it that you can possibly do it. I'm not saying it won't work, but they're teaching you to swim again using the, we're going to go in a kiddie pool first. All right. So you can use try catch to create an exception handler that catches any exceptions that are thrown. You code in the try block any statements that may throw an exception. You put in the catch block or blocks the statements to be executed when an exception is thrown. Now, the exception property, this is what we're going to use. It has three things associated with it. A message, which is the message that you get from the system that explains what went wrong. A stack trace, which shows you all the methods that were called before the exception was thrown. And it shows them from the last one to the one before that, to the one before that, to the one before that, all the way down to the first one. All right. Finally, there's a get type, which, as it says, shows the type of exception. When you print all that stuff out, it gets to be a little voluminous. When you look at that picture right there on page 209, hopefully what you can see by taking a look at that is it's pretty big. It's kind of ugly, but we're going to do that anyway, just so you can see it. All right. Now, there are, again, specific types of exceptions. And as I mentioned, you must go from the most specific to the least specific. All right. So if you're going to do an exception EX, it must always be last. If I had put this one up above at the top, none of those would ever get called because this is a more generic exception. Notice again, they put a finally in there with, as they say, perform cleanup. The finally is not mandatory. Now, when you look at this, this is a little bit deceiving, this picture right here, because notice what they have. Everything has brackets around it. Everything. All the catches and the finally. Okay? Well, you can have a try without any catches. You can do that. I've never done it, but you can. But if you have a try with no catches, you must put in a finally. Why you'd want to do a try and then a finally, I don't know. But you can do that. So there is example right there, and it's very similar to the one I just gave you. All right. Okay, it's 10:14, just went to 10:15. Let's take 10, come back at 10:25. We'll pick it up here on how to throw your own exceptions. All right, so I will see you back here. I'm going to get a new water. I'll be right back. See you at 10:25. All right, it's 10:25, so I'm going to continue on. The next section, as you can see, is how to throw an exception. The difference is, rather than the system throwing an exception here, you are throwing the exception. All right. And to do that, you use the keyword throw. And there it is. Now, there's a couple reasons that you might want to do this. All right. Number one, as they show in the example there, when you throw that exception, you can give it your own right there, your own text that you want. All right. Another reason that you might want to do something like that is that you literally can write your own exceptions as well. We're not going to get into that, and the book doesn't get into it, but it can be done. So you can see we're throwing a new exception, and then we're catching it down here. The difference is we're taking control. All right. What we're going to do in just a couple minutes after we finish the chapter is we're going to go back and we're going to rewrite this can I vote, and we're going to take all the stuff that we put in there for our checks, and we're going to replace them with numbers, with try-catch statements. All right. Now, the next they've got the future app or the future value app where they put in exception handling. So what you'll see in here, notice that they've got three exceptions that they're going for: format, overflow, and exception itself. This is the most general. This is more specific. This is most specific. So what's a format exception? All right. Usually with a format exception, that's going to be something like when we are expecting it to be a number and we put in a non-number value, something like that. An overflow exception, as the saying goes, and you're going to see all of these, is when you try to put 10 pounds worth into a 5-pound bag. What do I mean? Well, for instance, the biggest value you can put in for an integer is approximately 2,147,000,000 something. So if you put 3 billion in and the biggest value it could handle was 2.1 billion, you'd get an overflow exception. All right. And again, we've got our general exception at the bottom. All right. So when you see this, you're trying to do all this stuff. If everything works, if everything that's in here works, you skip all this. All right. And somewhere in here, you are calling the, where is it? There it is, calculate future value. So that's in another routine. So if for some reason, before you get to this line right here, if you have an error, the system will jump and say, oh, is it a formatting error? If it is, it'll do this. Oh, is it an overflow exception or error? Oh, it'll do this. Otherwise, it'll do this. Now, the only thing that it's doing is printing out a message box. Typically, you want more than that. All right. And if nothing goes wrong, if everything that's in here works, when you get down to this point right here, you call this routine, you do the stuff, you pass it back, boom, and then you set the focus back. All right. Okay. Now, one of the things that we talked about in that last example, the one that I did for you with a can I vote, is we did do data validation in there. All right. If you remember, I think I used the word verify. Probably could have just as well, I could have just as easily have used the word validate. All right. Validate age is not empty. Validate age is numeric, and validate age is within range. In fact, I'm going to do that rather than verify. It's going to give me some errors, but I'll fix them right away. Just means I got to come down here and change these to validate as well. Validate. All right. And it'll work the same. There's no errors in here anymore. I just renamed a couple things. All right. Did I have to? Of course not. But to me, it makes a little more sense to do that. Now, as it says here, when a user enters data, the data normally has to be checked to make sure that it's valid. Now, I wish I would have been smart enough that when I rewrote this, I would have rewrote it again and done the data validation, but I didn't. If I have time, I'll do that for tomorrow. Otherwise, we'll just look at the example in here, and we will look at that example anyway. As it says, when you check data to make sure it's valid, that's data validation. When an entry is invalid, you're in charge. What happens next? They say typically the application needs to display an error message and let the user know what they did wrong. And if possible, give them another chance to put in valid data. And as it says, this needs to be repeated until everything is valid. Well, when you validate, what can you validate? Not to be funny, but what can't you validate? So here, all right, this checks that an entry has been made. All right, this is all stuff okay? This checks that it contains a valid decimal value. This is what we've been doing. This checks that it's a valid range. This is what we've been doing. So we've done all that. So you're like, what are you talking about? Well, we can code, as it says here, we can code our own generic methods that will validate data. All right, why would we want to do that? Let's imagine that we have that program that we talked about before, where we're reading in first name, last name, address, city, state, zip code, email address, and cell phone number. We could make all of those and then write one is present or an is string. This is an is decimal. We could change it to is string, but we could check here now, and we have just one method called is present that we can call for everything that we're doing. I mean, that's what we want, because otherwise we're repeating a lot of the same code. And this way we don't have to do it. So the first example is just checking for the presence or the absence of something. All right. And this is what we're checking. And this is what it's called in all of these. Then we're checking to see if it's an is decimal. We could have an is decimal. We could have an is integer. We could have an is string, etc. There's all sorts of these we could write if we wanted to. Here is a range check. Is within range. Notice this is a little different. We have to give it a minimum and a maximum. All right. Now that I look at this, I do think I'm going to try to rewrite the can I vote tomorrow one more time. So we use these so you can see them in action, so to speak. But these are generic methods that can be called more than one time. All right. So here's another one that's called is valid data that's going to validate multiple entries on a form. All right. Well, notice what they're doing in here. They've got this thing called is valid data, and they're trying to do everything in here. This could have just as easily, and keeping with what they're doing in chapter 7 here, probably should have been a try catch. All right. But notice what they're doing. They've got a thing called error message at the top. They've got a thing called success at the top. All right. If any one of these fails, if is decimal, is within range, is decimal, is within range, is in 32, or is within range, if any of these fail, success will be set to false, and the error message will not be empty. But we have a plus equal because we could have multiple errors. So the plus equal says, oh, if we've got this, put in that error. Also, if we have this, then put in that error. And if we had this, and it's going to keep adding to it. So if we have multiple errors, our error message will be multiple lines long. But this is valid data. The key to this is the success and the error message. You are calling a bunch of different routines. What routines are you calling? The ones that we just looked at in here. So notice that's error message. We call it message in here. This is going to return true or false. Notice it's empty, but if there was any kind of error, now it's got a value in it. So we're either returning this or we're returning an empty string for each one of these. All right. And what's going to happen again is, let me go back to where I was. Oh, back one more. All right. Well, I guess I was here. It is going to check multiple and everything is valid data. So it's checking this routine. All right. Now, notice when we're setting success, if there was anything in that error message, if it was not empty, then we set success to false. We give a message box like this one, and we return success. So we'll either return true or false. So as it says, you can use the validation method shown in the previous figure to validate multiple entries. Then if any are invalid, or if more than one are invalid, you can display a dialog that shows every error that happened. And that's how they end this chapter. All right. They will end it by providing data validation for the future value app. All right. So if we look in here, doesn't really look any different, but now we get different errors depending on what you did. So here they put in a number that was too big. Here they put in the percent sign, which made it break. Here they put in nothing. So these three error conditions all were caught in the is valid type of routine. All right. And notice they threw an exception. So they show you the code in here for this. Now they did put it into a try catch. I mentioned earlier that it was possible to do that. All right. And what they're doing in here is very similar to what we have been doing. All right. Except first, it's in a try catch. And second, we're allowing the entire program basically to go through, where previously we'd kind of been stopping it when it reaches an error point. Here we're letting it go all the way through. All right. And then they've got it again, and they put in all these generic. All right. So is decimal, is in 32, is within range. So what do we need if I go back and rewrite this voting thing? We don't need an is decimal because we don't have one. We do need an is in 32. We do need an is within range. And we will have, even though it's not shown in here, if I back up, and is present. All right, so that's what we will have to add in here. And that's it for the chapter. Now, we're going to go back and rewrite this. But before we do, I just want to show you something, and that is this. All right. So far, I've been going through all these extra exercises with you. I'm going to continue to do so. So far, we've gone through all of these. We have done all these. You might have to go back to take a look, but we have done all these. All right. So what we're going to do now, but tomorrow, is we're going to go over the 4 of these. It's actually pretty well done. But what they ask you to do here is to create a simple calculator. We'll do that. And I'm going to call it 6-1. All right. Then, so that's a regular calculator that we do first. Okay. It's even simpler than the one we've been doing. Okay. But we'll do it anyway. Then we'll go back and we'll add some stuff to the income tax calculator. Fine. We'll do that too. But the other two for 7-1, they're both working with the calculator still. What I want to do tomorrow is I'm going to write each one of these as a separate app. So I'm going to write 4 of them so you can see, because this is adding exception handling. And then it's adding data validation as well. So you can see all of this stuff in action, so to speak. So that's what we're going to be spending quite a bit of time tomorrow on, just so you're aware of that. Now, I want to show you something. You may know this, you may not. This is not a gee whiz type of thing, but I just wanted to show it to you. So far in here, and I added this comment, assume that the legal age for a person to vote is 18, write a C# program that lets you input an age, verify that the text box is not empty, that it's numeric, that it's between 1 and 125. So nothing new there. All right. But I'm going to show you something that you may or may not know that you can do. All right. So I'm going to come in here. I'm going to leave this up. All right. And I'm going to create a new solution. Right mouse click, choose add, new project. It will be a Windows Forms app. And I'm going to call this one, Can I Vote Exception Handling? All right. So there's that one. I'm going to come in and immediately change, as always, to this, to FRM, Can I Vote Exception Handling? All right. Yes. And I'm going to change the color right away. In fact, let's just change the text on here to Can I Vote Exception Handling? All right, which should change it up here, and it did. Let's quickly change the color. I want to use something light. Let's go to green. That's fine. Now, what I'm about to show you, like I said, no gee whiz, but you may or you may not know this. All right, I'm going to go back to here, and I'm going to highlight everything. Control A, Control C to copy. Okay. Now I'm going to go here, and I'm going to do a paste. Okay. It copied everything over. Not only did it copy everything over, it kept the names. LBL input age, TXT input age, BTN calculate, etc. I'm going to change the color of these two to green because it looks kind of poor the way it is. So I'm going to do that. All right. Why did I even tell you that? Just to let you know that you can do that. It copies over most everything, but not everything. What do I mean? Well, if I go and click on the form, there is no accept button set. That doesn't copy over. So I have to manually set it to calculate. There is no cancel button set. So I have to go in and set that to clear. All right. There is no start position set. So I will set that to center screen. And the interesting one in my is tab order. We're going to look at that in a minute. But if you remember from before, it was 0, 1, 2, 3, 4, 5. Well, if I go now and click tab order, view tab order, it came back with 6, 7, 8, 9, 10, 11. Since I copied that stuff in, it kept the old tab order. All right, so I'm going to reset it to 0, 1, 2, 3, 4, 5. All right, do another view tab order. All right, and everything should be cool right now. Now, the other thing I'm going to do is I'm going to come back to here. I'm going to grab the comment that's at the top. I'm going to copy that. And I like to get rid of this stuff. All right, so there's my comment. I'm going to come in here and I'm going to copy in my declare and initialize constants. So there's that. And finally, underneath this, I'm going to come in and I'm just going to copy in all the code that I had. So virtually what I just did was I'm making these two copies of one another. Now, I could go in here and do this. That's not, don't do that. All right, what I mean is go back to here, double click on each thing that's in here, calculate, clear, and exit. If you don't do that, if you just go in and copy in all this stuff, it usually does not update your designer file. All right, it'll put those out of whack, and the program, for lack of better words, can easily get screwed up. For now, at least, I'm going to copy everything from here. So this is what's in my calculate. All right, don't worry about that. We'll fix these in just a minute. We haven't copied those in yet. So, all right. These are user written methods, so I can copy these verbatim. My validate methods, my determine voter status, all that stuff. So I can copy all those in. And I'm going to put that right here. All those errors should go away now. All right. Well, my show error go away because I didn't copy that in. There's my clear form, and I'll copy in this. So again, this will be clear form. Paste that in. Now that error went away. All right. And in my exit, I'll have the old exit programmer not that I've been using virtually all semester, and my show error message. All right. So in other words, and it probably took me about 5 minutes, I cloned this program. You might say, well, why didn't you just like copy it? That doesn't work well in here. All right, just literally making a copy. I mean, I have found out over time. But right now, if I do a file, save all, and I change my startup project to this, exception handling, all right, and I run it, it should work exactly like the other one worked. All right. Okay, so it appears as though it does. So I didn't do that just to show you how you can do a copy. All right. No, what I'm going to do is I'm going to rewrite what's inside of each one of these verify routines right now. I shouldn't even say that. I'm going to modify what's inside of each one of these. I'm not verify, validate routines. All right, so I'm going to start with the first one, which is that validate that it's not empty. All right, so we'll do that. Then we'll go in and we will validate that it's numeric. Then we'll go back in and we'll validate that it's within range. All right. Now, if I was more talented than I am, I'm not. I would go back then and write one more copy and put in all of those generic validation methods. I don't want to do that in front of you because there's a real good chance I'll screw it up. All right. So I'm not going to do that. So I will go in after class today and attempt to rewrite it using those generic validation methods. If I can get that done, then tomorrow, when we come in, we'll do that first. Then we'll look at these exercises that I mentioned to you earlier. All right, so let's start again with validate that this is within range. I'm sorry, validate that it's not empty. All right, like I said, there'll be some rewrite on here. There'll be some stuff that's the same. All right, I don't need a ret val anymore. That's first thing. So where I've got ret val in here, I'm just getting rid of that. Okay, but I'm starting with this age string, just like we did before. In other words, that's grabbing what was in that text box and it's putting it in age string. Now I'm going to put a try catch block in here. All right, and I'm going to try to catch a special exception that's called an argument null exception. What does argument null mean? It means we didn't put in something. Well, we're checking for something being empty, so that seems to me like it makes sense. So I'm going to do this. And again, you're getting all this code. So if we left this empty, I'm a new argument argument null exception that I'm going to handle right down here. If I didn't, that meant it wasn't empty, so I'm going to return true. All right. Somehow I lost my curly there. So what is this doing? This is saying try. So if it's empty, throw this exception, but pretend that isn't there. All we're doing is we're returning true, meaning, yeah, age was not empty. There was something in there. So what do we want to do here? All right, guess what? All I have to do is remove this if, bring all this in, put it in here. Okay, but there will be one more thing I have to do in just a moment here. All right, and that is here I'm returning true, but here I want to return false. So look at this. All right, what we did previously to this was we used an if, but we didn't work with exceptions. We didn't let bad data in the system. Now, if bad data comes in, we're calling that exception. We're giving it an error message. All right, we're setting the focus and we're returning. And you could say, well, aren't you basically doing the same thing? And I'd say to you, yes. All right, so this one should be working now. So let's try this one. This is the only one I'm going to check for right now. So there's nothing in there. Nothing in age text box. Age cannot be empty. And there's my cursor. If I do put in a valid number, okay, it's going on. It returned true. So that all worked. Everything we did now in validate age is not empty, worked. Now, could we have checked for other exceptions? Yes. For instance, I could copy this down. I'll leave this in here. I wouldn't probably do it, but I'm going to just put in here exception EX. All right, and I'll just put in here some other problem occurred. All right. And then here I'll just put down error in code. I don't know what it is, but something happened. All right. Now notice on here, I get the green squigglies here and I get the green squigglies there. All right. This is my message right here. This is my message right here. But I'm going to add to this in both these cases. I'm going to put in the system message as well. Okay, I want to know what the system gave me for a message. Okay, so how do I do that? Well, just so I'm sure I know which is which, I'm going to put in here system message. All right. And after system message, I'll put in a \T for a tab, and I'll do plus to add, and I'm going to say this ANE dot, and notice the first thing that comes up is message. So now I've got the system message in here. Now it's giving me an error, and it's giving me an error because I did it wrong. This has to be not a comma. This has to be, whoops, this right here has to be a plus sign because I'm just appending here. It's gone. All right, and I'm going to do the same thing down here. All right, but it's a different exception. It's EX. All right. Now, what changed? I mean, you're like, fine. Do I even have to care? Well, let me put in a couple line breaks here and a couple line breaks here. This will be the system exception. That'll be their message. This will be my message right there. All right, so let's run it again. And again, I'll leave it empty. Now notice the system message is value cannot be null. My message is age cannot be empty. All right, if I want to, I can also put in here, I've got the system message, and I can put in the system type. This one I'll probably screw up, but we'll see. I think it's get type dot name. Yeah. All right. I might have to put a .toString on that. I don't know. Plus, well, it doesn't like something in here, so let's see. Exception dot get, oh, means it needs parent. Okay. So now I've got the system type in here too. Let's put another line break in there. And you're going to notice this is going to get bigger. All right. So there's the system message. There's the type of exception that got thrown. What's nice about this is notice it's argument null exception. That's the type that was thrown. All right. And I can go back and verify different things if I want. The other thing I can do in here too, let's put one more \n in here. And I'm going to put in here one more time. Oops. Yeah. \n \n and a system dot stack system trace, we'll put. And that one is an ANE dot stack trace. I think that needs parens as well. No, maybe not. Comma. All right. So now, again, you're going to see it doesn't like something here. No overloaded for show message takes 3 arguments. Oh, yeah. It doesn't know how to understand this now because our show error message is only taking this stuff. So that means that someplace in here, there it is. I need another plus sign. All right, so I'm going to run it again. And I'm going to leave it blank. And notice how big it's getting. It's showing me what the system error message was, what the type of system message it was, and the stack trace. So I can figure out if I go back through my program, maybe what screwed up, where it screwed up. And then there's my message. All right. Now I'm only going to do this as far as the type and the trace just this one time. All right. But it can be a really, really, really nice debugging tool. All right. It can help quite a bit when you're going through here. So let's go down to the next one. And now we're going to validate that the age was numeric. Again, I don't need a ret val. I can keep my result. and I'll keep my age string. All right. And this will allow me to do something kind of neat in here. Another try. Another catch. Now I'm going to be catching not an argument null exception. All right. But I don't know if it would catch an arithmetic exception here or not. Let's try it. I used argument exception, but I'm going to try an arithmetic exception. AE. All right. So what are we going to do in here? Well, very similar to what we tried before. What do I mean? Well, we're going to bring in this. Attempt to convert this. Notice I'm getting an error. I'm not bringing in age. Guess what? I don't need to use the age yet. Wrap your head around that. I don't really need to know what the age is right now. I only need to know whether or not it is numeric. Since I don't need that value, I can discard the value that's in there by putting in an underscore. All right. So here, if it returned false, what do I want to do? Well, what I want to do is I want to throw a new arithmetic exception. All right. And then when I catch it, just like before, I want to do all this stuff. But we don't have that ret val anymore. So let's get rid of that. And if this succeeded, we want to return true. And if this failed, we want to return false. All right. And again, I'm going to copy this over. So I'll have the system message, and it'll have to be an AE. Okay. But again, we're virtually doing the same type of thing we did before. The difference is now we're using exceptions rather than if statements. All right. And you might say, which is better? We're going to go over that as soon as we finish this program. All right. So now if I file, save all, and I run this again, you've already seen nothing in there. All right. Now let's try putting a non-numeric. All right. So the system overflow or underflow in the arithmetic operation. That's kind of a weird message. All right. But it's the message. All right. So we've now handled those two things. So the one that's left is a range check that we're going to do in here. And just like before, now we do want this because now we do need to know the age. All right. And we're parsing it. We know that it already worked because we checked to see whether or not it was numeric. All right. But again, we'll come into here. We'll put in our try. We'll put in our catch. All right. And just like before, this will go into this. Will stay right here. And this, rather, this check is going to go into our try. All right. If it was bad, what do we want to throw? Well, there is an exception for this. And the exception is throw new argument out of range exception, which to me seems like it makes sense. All right. And that means we have to catch that. And I call it AOORE, argument out of range exception. And what do I want to do? Well, remember, if this succeeded, we want to return true. All right. And I'm going to copy all of this, put that in there. I've got too many curly braces now. Sorry. There. All right. The only thing to do is to return false here. Okay. Now I didn't add this. I've left my parens off of here, and I didn't add this. So let me come back just like we did before. Let me grab that. And I'm going to put that here. And this is now AOORE. All right. So now, and I really didn't do all that much. All right. But I've gone in and I replaced all of my if statements with try catch blocks. All right. So let's do a file, save all. Let's run it again. So you've already seen nothing with all that stuff in it, non-numeric, now out of range. All right. Specified argument was out of range of valid values. Okay. And since I copied the other thing over, which was just making that check, there's no try catch to do in here. All right. So again, if I come in and put a 1 in there, no, you can't vote. If I put in a 17, you can't vote. If I put in an 18, you can vote. If I put in 125, you can vote. If I put in 126, you're out of range. All right. So what I've done literally in a matter of minutes is to go and convert one of these into the other one. So as I mentioned to you before, a natural question then is, okay, that's fine. Which one's better? Well, I went out and Googled it. I'll tell you which one I think is better is to use ifs like we have been doing. But I went out and I eventually found Stack Overflow. All right. And try catch or if statement. Okay. Now, this was 10 years ago, but there's one even longer. Is it bad to use try catch? Okay. So they have somebody who came in here and did this. They used a try catch. And they said, well, you should go here. And that was the other one we'll look at in a minute. But I like the answer to both of these. You should not use exceptions for control flow because it is considered bad design. Exceptions are for exceptional cases, not for your flow of the program. All right, and if we go back to the other one, try catch should be used when you validate, but some strange things can happen and something causes an error so you can handle it more gracefully. In other words, most programmers, I believe, would tell you that they think that it's better to use if statements to keep the data out of the system than try catches where you let it in and then try to handle it. But one of the things that we're going to do next week before you take, when you take your next test on 6 and 7, is we'll go back to one or more of the programs that we have done previously with ifs, and just like we did here, we'll convert them to try catch. All right. And for your next week, I'm going to have you do a relatively simple program for your pretest, but we will write the same thing both using an if statements, and with try catch. All right. So you'll get a chance to see both of them, all right, in action, so to speak. All right. But again, with much of this stuff, it really and truly is, it's going to be what you think makes more sense. All right. I mean, you could be pretty darn specific when you start going through this. If you knew there was some kind of a weird input output error, for example, boom, you could go through there and you could check for one or more of those errors. and be very specific. All right. So some people use this on a fairly regular basis. Most programmers that I have come in contact with do not. All right. So what we will do, I'm just about finished, believe it or not. All right, I'm gonna let you go a little bit early today. So tomorrow, again, I'm going to attempt right now, right when I get done producing this and putting it out there for you, I'm going to attempt to go back. You'll see it. All right. And I'm going to attempt to write one more of these. So I will and do an add and a new project and the Windows forms. And this will be, can I vote with data validation? And I'm going to write it with those data validation things. I'm going to do just like we did before. I'm going to copy in just like I showed you before. All right, I'll do that. Okay, I will put the completed video out there on the system. And then later this afternoon, when I get this working with those generic routines in there, I'm going to grab them right out of the book. All right. I'll give you the URL will be to right here. So let's see. It will be to this one's already out there. This one's already there. Calculator Many. But I will have the Can I Vote will be out there later today, and it'll have 3 versions. The one version that we did first, that the simplest version with the if statements, the one we just completed that has the exception handling, and then finally I'll combine the exception handling and do it, probably at least. What I'm going to use for my I don't know, a template or whatever you want to call it for this is I'm going to use this one, the Code for the Future Value app. I'll have all of this and then this as well. So I'll put in, again, I'll have an, there's no decimal in there. I'll have an is in 32. I'll have an is present, and I'll have the is within range. All right. And then down here will be the, determined voter status. All right. So you have some kind of an idea what's going on. So if I get that done, and hopefully I'll do it, if I will get it done fairly quickly, we'll go over that first thing tomorrow. Then we're jumping right into those extra exercises, which I'm going to do each one individually. So we'll have 4 different apps that we do tomorrow. And again, I'll put that out there as well tomorrow. All right. That's really all I have. If you did not turn in your test, you better pretty soon. All right. If you didn't finish the test yesterday and you haven't turned anything in, you're going to lose points. I'm trying to be as fair as possible to everybody and to the people who did turn the test on time. Finally, again, you've already seen this. You've already got this in an email. Jacob Weinrich, I don't know, is the person who has volunteered to be a tutor for the class Monday, Tuesdays, Thursdays from noon to 4. Any hours outside of that, you have to request. All right. The other thing, just so you know this, is, if 10 of you go and ask to be tutored by this guy, let's just say, I believe that tutors can only work 20 hours a week. I believe they cap it at that. All right. So he may have to tutor more than one person at the same time. I don't know exactly how that works, except years ago when I had a person who was tutoring, that's how he did it. He ended up having about 6 students. So he tried to come in and said, hey, I'm going to be available during these times. And then people would come in during those times. And he did it like that. Okay. So that's, like I said, that's all I have. I will talk to you tomorrow at 8:05. Have a good rest of the day. Thanks.